So I'd just like to say hello and welcome everyone to this MGAA market briefing. It is so quick introduction and explanation, and I'll do some housekeeping and then won't delay you any further, and we'll hand over to our presenter. So yes, today we're covering AI, a practical perspective for MGAs, and it's delivered by Accelerant, and our presenter is Kenny Holmes. So some of you may well have attended part one of this. So it won't be a barrier to your learning if you didn't have an opportunity to attend the first session. But if you did want to recap, it is available in our on-demand section. So just to let you know that. So before I hand over, just a little bit of housekeeping to do. So a polite request, please, to keep microphones and cameras off, just to help with technology, and try our best to keep us all present and in the meeting until till the end of the session. And also, can I ask you if anyone has activated any AI note, which is particularly relevant as we are covering AI, but any AI note-taking facility, if you could disable them, please, as we don't have everyone's permission. So that's my don'ts, and as I usually do, I do have things to encourage you to do, which is to ask questions. So if you can use the chat facility and ask your questions as they come to mind, and what we'll do is either hold them to the end, but it may be between sections a bit a relevant time to pop that question in for Kenny. So yes, please ask your questions as we go along. Other things to remind you is that the session is accredited by the CII for CPD purposes. So if it does meet with your training needs, then, or your knowledge gaps, you can add that to your CPD log. So I think that's everything that I need to cover. I think Zoom is very efficient and usually does tell you that the session is being recorded, but just to remind you, it is being recorded, and that does mean that if you wanted to review the content, it will be in our on-demand section in the member area, and I'll also send you a link to it. So if you wanted to review or pass the link on to colleagues, you can do. So that's my bit over and done with. I will hand over to Kenny Holmes from Accelerant, and he will take it from here. Okay, thank you.
Amazing, thank you. Good afternoon, everyone. Great to be here. Thank you to MGAA. Thank you for everyone who's come to listen to the talk today. Let's get started. So a bit about me. I'm Kenny. Good to meet you all virtually. I'm Chief Data Science and AI Officer at Accelerant. I lead the application of data science, machine learning, all things AI, basically fancy accounting at Accelerant. We'll talk more about that in a moment. For those of you who don't know, Accelerant connects specialty insurance underwriters with risk capital partners. We are all about MGAs. We spend most of our time trying to help MGAs be more successful. So it's great to be talking to you today. I guess the main thing that I would tease out from this is really where I'm coming from a background perspective. I'm a nerd. I'm a technical person. I think as AI has entered the popular vernacular over the last couple of years, you've probably heard a whole lot of stuff. There's lots of people who've got involved in AI, lots of excitement we're going to talk about today. I approach this not as a new entrant to the space, but as someone who's been doing this my whole career. I started out as an academic physicist, so science was my first passion. I get very excited about models and AI and all that good stuff. I couldn't make enough money in academia, so I decided to become an actuary. I got bored, and then I moved into broader fields, doing things, more advanced things with models and AI and machine learning and all that good stuff. So a warning, there'll be some not overly technical elements, but I'd really like to try and get under the hood a little bit about what AI is, what it isn't, and where I see the opportunities, particularly in the MGA space as being. Okay, what are we going to look at today? We have four main sections. So number one, where most of the meat is, understanding AI in practical terms. So as I said, what is it? How can you conceptualize it? How should you think about it? Secondly, we're going to look at where AI fits within P&C insurance as the market starts to adopt this technology. I want to lay out a framework for some different high-level use cases, and also give some examples of some advanced use cases. Most of these come from my observations, our observations of the trends that we see in the market. They're not necessarily excellent things, but in places they might be. The third point we're going to touch on briefly is on regulation and fairness. You will all be aware that insurance is from a regulatory perspective, a high-risk endeavour. We deal with customers. Our customers have rights. AI models present a unique opportunity, but also some very specific threats when used in combination with customers. So we're going to touch on that. Yeah. And could you guys make sure that you're unmuted, please, if you come off mute? Thank you. And then fourthly, we're going to look at some practical tips for how MGAs could leverage AI. Now, I've made some assumptions there, and the assumptions are that although AI seems to be everywhere these days, I'm assuming that most MGAs are probably at the point they're starting to start their journey using AI. Some of you may be further down the line, some of you less so. Maybe you haven't used any AI tools whatsoever. So I want to give my opinions on how you could maybe get started, because I think there's tremendous value there. We'll have some question and answers at the end, but also if you have questions in between, then feel free to unmute, or however you do that on Zoom. I'm happy to take questions as we go through. Okay, I'm not going to dwell on this because we will recap at the end, and it's rehashing what we saw before. These are the learning objectives. We will come back to these at the end of the presentation. So we said at the top, this is one of a series of 3 presentations given by Accelerant. The first one was in April by Chris Lee Smith, our co-founder. Today we're looking really deep diving on AI, and in October we're going to be having a deep dive on our member services by our member service team, and all the ways that we try to help our members, our MGAs, be more successful with products and data and services. So I hope you can make that one. I think it'll be very good. Okay, that was a big preamble. Let's get started. I think it's impossible to, well, perhaps not, but I think it's impossible to have not heard about artificial intelligence. It seems like every single news publication, within the news, within trade publications, within LinkedIn, you speak with your friends and family. I know my children talk about it constantly. The rise of AI has just been completely possible to ignore. It feels like we are saturated with information about artificial intelligence. There are lots of different angles to that. So we have rapid productization of these things called language models, which we'll touch on. Concerns about how the adoption of AI will change the structure of the workforce. Concerns around job automation, or some of the promise around job automation, because there are probably pluses and minuses there. But the main thing that I wanted to start off with is you have probably heard a ton about AI. Some of that's going to be high quality information, some of it less so, and we're going to try and unpick some of that today. I wanted to start off with this diagram, which is trying to take a step back and look at AI as a development of the technology that the human race has developed. There have obviously been a lot of inflection points where we have, in large chunks, added capabilities that have become tremendously successful to us as a species. And that's kind of a grandiose way of laying this out and tacking AI on the end, but it's something that I fundamentally believe in. We are only really a few years deep into applying AI at scale across different industries, and it's already having a marked impact in many different industries. I think most people who spend their time working in this field see this genuinely as a new technological paradigm, which has vast opportunities to improve lots of different elements of the human condition. So I'm super excited about this. I think it sits in the same kind of place as some of these different paradigms here. If your favourite technological revolution is not represented here, then I apologise. It's not my diagram, but just for to try and put in perspective. With any new technology, there is always noise. And when I say noise, what I mean is people get excited. There's potentially misinformation, over-promising, short-term opportunism, people trying to sell you things, selling selling things that perhaps are not well understood by those who sell them and or who are buying them. The diagram on the right is by Gartner. They're a consultancy that analyze technology and technology trends. They publish these kind of diagrams, which they call their hype cycles. They do it for different kinds of technology. This one was from last year, specifically around AI. And the observation that Gartner have is that they have this characteristic hype cycle where a new technology emerges, and there's a lot of hype, expectations, often mania around how that technology might be applied and might be used. And then you see a characteristic trend of perhaps the hype dies down and eventually you end up in a place towards the right of that diagram where the world is better for the new technology, but you've worked out all the bugs and you've kind of put that technology in its rightful place where it sits with the broader endeavours that you have as a business. So this diagram, this peak and trough, is not really a technological statement. It's about how humans adopt technology. So I think it's safe to say that many technologies go through this kind of peak and trough. From our perspective, from my perspective, cutting through the hype, there is real practical value in applying AI. And we're going to look at some of the different applications that we have here today. Okay, I keep saying AI, artificial intelligence. I just want to pick at that a little bit because, as I said, I'm more of a technical person, so I like to describe things in terms that at least make sense to me. Hopefully they'll make sense to you. So what practically is AI? And there are these things called models. And you get lots of different kinds of models. They are mathematical objects. I've laid out a diagram at the top that has input data, model, and output. And simply stated, it's a mathematical calculation that you put some data into. It combines its inputs in some way and then spits out an output. So an example might be of a simple model. I assume all MGAs are going to have a rating model to help them price business. You might input the data around your insured characteristics. Maybe it's a building, it's a total sum insured, it's the customer. That flows into, for instance, a spreadsheet. There's some calculation, some addition and some multiplication, and out pops potentially a price. So we would call that flow a structured data flow. So the data that you're putting in could exist in a database. There are simple numbers that describe the total sum insured, the type of building, the postcode, yada, yada, yada. And you combine those in a way that output a price. Models can also accept what we call unstructured data. So unstructured data is informally data that doesn't belong or doesn't live nicely within a database. So what doesn't live nicely within a database typically? Images, free-form text, audio recordings, things like that. And the point that I want to make, and I may be laboring this a little bit, is that models are tremendously flexible. You can have different input data and different output data, but the bit in the middle, the essence of the model, is calculation logic. They are simple statements. It's addition, it's multiplication, it's if statements, and every single model shares those constructs. What differs between traditional models and AI models is scale. AI models tend to be much bigger. We're going to look at some examples in a second. And although the individual calculations within them are simple, there are many, many of them as part of the system. So they become difficult to describe in totality because there are so many numbers to describe if you want to describe what's going on. Okay, second level, what is AI? We said it's a model. Well, it's typically large, flexible models. I've laid out three different levels here. This is an entirely arbitrary definition. You could have different ways of referring to different classes of models, but I started with, at the top, actuarial and statistical models. I started with those because I think that most MGAs will be used to either using them or being judged with reference to them by their risk capital. And the defining characteristic of actuarial and statistical models is that they typically are based on strong assumptions, business knowledge. They're designed to be simple and transparent and auditable and comply to regulation. At the right-hand side, I have a list of numbers saying parameters. And parameters in this context just means how many numbers describe that model. So I've got here, I think I have 1,000 parameters. And what that means is that for a particular actuarial model, let's say it's a pricing model, there are 1,000 numbers within an Excel spreadsheet that perhaps are different base rates, or you're multiplying different numbers, but you could describe the model exactly with 1,000 numbers or 1,000 if statements, if you prefer thinking about it that way. The next level down, we kind of get a little bit more advanced. We start talking about machine learning. Machine learning is kind of, you can think of as an extension of actuarial and statistical models, which is less based on assumptions, and it's more based on letting the data do the talking. So essentially, the models are derived by data-driven modeling. So you feed data at scale into a computer algorithm, and it finds the patterns for you rather than being helped to find them, which is the process that you might have within an actuarial background. So if we look at how many parameters, how many pieces of information are contained within a machine learning model, it varies, but let's say about 1 million. So we've already gone from 1,000 if statements to 1 million if statements. It starts getting more difficult to conceptualize. It starts getting more difficult to describe what's going on. If we go down one more level to the AI models, this is kind of a meta field. It's a broader field in which everything else belongs. So machine learning and actuarial statistical models all belong within this broader field of AI. Typically, these AI systems, the way that we typically conceptualize them is that they perform tasks that we once thought needed human intelligence. So they are good at working with unstructured data and working with things like language, vision, or trying to approximate what decision-making looks like. But what I wanted to lay out here was that as we go from top to bottom, it's all the same kind of calculations, and I'm saying flippantly it's if statements, but what broadly is all if statements and multiplication. The difference here is scale. As we move top to bottom, we have more data, more unstructured data, more flexible models that are better at finding patterns, and bigger infrastructure and computers to run those on. So for the AI model I have here, the latest models that are being released just now in terms of number of parameters, we're at about 1 trillion. I think 1 trillion is 1 followed by 12 zeros, I think. So quite complex. You need some big computers to be able to use these models. Okay, third level of what is AI. So I said they're models, they're big complex models that work with unstructured data. Probably a more natural way to think of them as they're models that have a set of human-like capabilities. So I have on the left, I think a useful working definition to bear in mind is an AI model is a system that can perform tasks that, until recently at least, we assumed required human judgment or intervention. And I have a couple of examples here. The middle column, I think you would agree, there's a picture of a panda there. And if I asked you to show this picture to a random human person and said, what is this thing? I think most people would say it's a panda. I think we'd agree on that. And in fact, most children would say it's a panda. I've got an example here of a 4-year-old child saying panda. And one of the things that we find, or one of the things that we know, is that humans have intelligence. We are very good at spotting patterns. We're very good at playing out scenarios in our mind. This recognition is part of the human experience. We are naturally very good at it. We evolved to do that, and we are very good at it from when we are very young. If we look at how an AI model would have answered this question in 2010, so that middle line in the middle of the page, there were vision models that existed 15 years ago, but they were terrible. So an AI model 15 years ago might say this picture of what objectively is a panda. It might say it's a dog, it's a grape, it's an engine, and that's not being disingenuous in how good the models were. They were terrible. I remember, I lived through it. The real story here is as we move from 2010 to 2025, the amount of data, the technology and the models have developed so much that this problem becomes almost trivial for algorithms to solve. So these vision models in this example will say it's a panda, and they're pretty much 100% accurate of what it is. There's not really much uncertainty in that. The example to the right, moving more towards an insurance application. So we have a claims note, a made-up claims note with a spelling mistake in it. If we gave that to a claims adjuster, they would probably look at this and say it's an escape of water claim. They'd probably tell you a whole bunch of context about how escape of water claims tend to play out, their experience of managing different claims, the complex ones, easy ones. There's a lot of knowledge contained within that human mind. Similarly, if we'd asked an AI model to analyze that text in 2010 and say what's going on here, it might say, well, there's a vegetable in a swimming pool here, because the claims note mentions a pool table and a leak misspelled as a vegetable. And again, that's not being disingenuous. The systems were tremendously poor. And again, what we see with text data, models have come up so far that we have systems these days that are able to accurately tag and meaningfully give information from free-form text, which is tremendously useful. So I guess the point I wanted to make here is if we were 5, 10, 15 years ago, and you'd said to me, Ken, can you make me a system that takes pictures of car crashes and classifies what's happened and how much the damage is. 15 years ago, I would say, okay, give me £10 million, 5 years, and I will deliver a disappointment. These days, the technology has moved on so far that the models have become so adept that even non-experts can start to put together systems that actually become performant. They are by no means perfect, but they certainly are much better than they used to be, and they are certainly a multiplier to human capabilities. They can help form a first estimate, or they can help automate very simple tasks. Okay, the next point I wanted to touch on is that AI is not really just large language models. Large language models are probably the most productized kind of AI model that we see today. Those of you that have used these tools, you may have seen, heard, or used of ChatGPT. That's one product from one company, and there are lots of other products from different companies that do similar things. These are essentially advanced chatbots. An example on the right, where you can ask it questions, and it can emulate a human interaction, at least in text. And that's kind of the point. Large language models have been deliberately designed and trained to emulate human conversation, and they can semi-reliably recall facts, extract information from other data sources, and answer questions. And the reason that I think large language models have become synonymous with AI from a public point of view is really just because these are the first products that have really come to market that people can get their hands onto. But AI is a much broader field. We saw in the previous example, we had vision. There's systems that are specialized to extract information, summarize information, break up tasks into sequential steps, try to reason or try to emulate reason. So if you've played around with large language models, it's a great starting point. But AI is broader than that. It has a whole bunch of other models which are useful in different contexts. Okay, so there's been a lot of positive stuff about AI so far, how the models have come on, how big and impressive they are, the kind of things that you can do. A couple of reality checks. The first one, are AI models intelligent? I would argue that the question is really irrelevant. I think that what a better question is, are they useful? But I do think that the way that the popular conversation has progressed is that we tend to talk about AI systems in very human terms. So they think, they learn, they understand. If we go back to our panda picture on the left-hand side, I've exposed the panda picture to two different systems. One of them is a squishy human system with a person like you or me. And I would encourage you just to think for a second, look at the picture of the panda and think about how that resonates with you. What kind of images, what kind of understanding is created in your mind if you take a moment? So the first thing you might say is a panda. Say, correct, it is a panda. You might then imagine what it's like to walk around the panda. You've seen the front of it. Can you imagine what it looks like to walk around the back? Can you imagine what it might feel like to touch a panda? I'm assuming you haven't touched a panda. I haven't. Can you imagine feeding it? Can you think of the connotations that pandas have with China? different cultural connotations. And I guess the point that I want to make here is that when you're exposed to this image, it generates a rich mental model in your intelligent mind, which has lots of different dimensions to it. And that enables you to conceptualize and view what you're looking at in a broader context. You can imagine interacting with it in the real world. If instead we go down the right-hand path and we show the panda image to an image algorithm, it doesn't see all of that depth that you can see. It sees collections of pixels which have patterns. They have statistical patterns. And the algorithms have seen so many pictures of pandas that as soon as you show it to them, it says, okay, some pixels are flashed here, some pixels are flashed here. These are black, these are white. It looks slightly different from this other example, which is a zebra. I'm pretty sure it's a panda. And I guess the point that I want to make here is that although it seems magical, that a system can look at something and identify it and tag it as a panda in this case, and that's a process that we traditionally thought required human intelligence. It doesn't require intelligence. It's statistical pattern finding. And the point I want to make is that I think it's natural to attach these kind of human concepts to systems, but I think it's often counterproductive in the sense that often people's trust in systems could come from believing that there's some deep innate intelligence contained within them rather than statistical pattern finding. And I would encourage you, as you use AI, particularly in sensitive applications, to really consider these to be statistical pattern finding machines rather than intelligent agents. And I think if you think about it that way, you're going a long way to equip yourself with a robust mental model for using AI appropriately. So reality check number one, is AI intelligent? No, certainly not intelligent in the human context. Kind of an academic question, focus on whether the thing actually works and whether you can demonstrate it works. Reality check two, don't worry, I'm not going through all of these, but you will have a copy of the slides. There's a few elements here of some other rough edges and areas where we're still working through making AI robust and applying it in different use cases. There's a couple of lighter ones that I'll just mention briefly. The top one is bias and discrimination. And that's this idea that, for instance, if you take a large language model, these are models that have essentially been trained on the corpus of entire human text knowledge. Like you take all of Wikipedia, you take religious texts, you take published works, and you get all of that data into a computer and you build a model on it. Bias and discrimination comes from the fact that a lot of human history has been problematic, and a lot of human history, at least recorded human history in text, comes from a world that has a slightly different shape and it has a slightly different idea around what fairness is than we have today. So there's a real problem, and this is not an academic problem, it's a real problem, that systems perpetuate biases which can be harmful, illegal, and a lot of bad things. And that's something that happens actively unless you take active steps to minimize that. Second point, accuracy. AI models are very good at generating plausible outcomes. So you could enter in some text and it will give you a plausible description of what's going on or answer the question with confidence or apparent confidence. There's a difference between a system giving an apparently confident answer and that being right. And one of the things that you will have noticed if you've used large language models in particular, they often get stuff wrong. So accuracy is a real problem. You should not trust these systems to be correct all the time, particularly in high impact decisions. We've got one highlighted on privacy and security. It's necessary to use some of the most advanced models. Those have to be run on special infrastructure. They are products that you license, that someone else takes your data and runs the model on it. Whenever you do that, you're sending your data, potentially sensitive data, potentially data that contains PII, whatever, to another party. We've seen many instances, both within insurance and across different markets, of people taking more risk than perhaps they'd appreciated they were taking. And the point I wanted to make here is to remind you of your responsibilities in managing your customers' data and take privacy and security very, very seriously. Last light point, we're going to touch on this a bit more in a moment, is around regulation. The regulatory framework is evolving rapidly. These tools are obviously becoming very popular, very easy to use. They're being used in more regulated markets, like in transacting insurance, and regulators are spending a lot of time investing and building frameworks. There are lots of them, and it really pays to keep abreast of what's going on in the regulatory frameworks, because it can impact how you can actually use these practically within insurance. Okay, so I wanted to start looking at some different use cases of where you can start to use AI in different areas. I've got 4 high-level use cases here. It's the way that I think about it, at least the way we think about it at Accelerant. So we'll start at the top. We have the first column, the first row, sorry, referred to as everyday AI. And what I want you to think of as the use case there is it's you as an individual who goes about doing a bunch of tasks every day, interacting with an AI model, like a large language model, to try and help you get more productive. So it's using, for instance, ChatGPT. I'm not endorsing ChatGPT, but for instance, using an off-the-shelf tool and using that to enhance productivity, planning, summarizing. There are commodity tools that exist here. You don't need deep experience. There's definite value to be had here, and you can see the impact of some of that in the short term. I've highlighted this one because if you're at the beginning of your journey using AI, it's a sensible place to start. And I really wouldn't underestimate the potential value that you can get from a personal perspective as you go about your day-to-day work. From my point of view, I started using these commercialized tools a few years ago, kind of at the beginning. And almost every single aspect of my work has been enhanced by using AI. I use it all the time, which is probably not surprising. Next step down, workflow optimization. So that's going beyond using a chatbot and having a conversation with it. It's really maybe starting to tweak some of the settings in these models that you can license and you can buy. Typically have some settings that you can tweak to make them better at solving a particular problem that matters to you. So perhaps your business receives a ton of emails that you have to get some information out of. You can tweak these AI models and using human language in a way that can help to start to approximate that task. And you can test whether it works or not. So with minimal effort, you can start to create AI tools that are more customized to problems that matter to you. Moving down, we can look at customer interactions. So the idea is that us, in the last example, we talked about workflow optimization maybe being glue that helps you move data from one place to another. Another major bottleneck the companies face is in talking to customers and talking to each other. There are many interactions with customers that don't have to be as deep as they are. They don't need as much time invested in them. It's a simple query of something that you know the answer to. So by using AI to enhance customer interactions, particularly low risk or more routine interactions, you can start to free up resource to focus on the more difficult stuff. Last row here, performance intelligence. So we work in P&C insurance broadly. Obviously, insurance is its own business model. It's a complex business model. There's a dynamic profitability landscape. There are claims trends. There are legal reforms. There's a lot going on. And the idea is, can you use AI, machine learning, any form of modeling to enhance the resolution and or speed with which you identify patterns and make strategic decisions? Now, this obviously starts getting more complicated. There's more data going in. The models become more bespoke. This bottom one is where I spend most of my time, unsurprisingly. And the point that I wanted to make here is that AI, machine learning, collecting data, and using that to analyze the performance of businesses is tremendously valuable. We're collecting more and more data than we ever have as a species, and being able to analyze that with new tools presents unique ways that we can create more value. What's the downside of that? It takes some expertise, it takes time, it takes scale, and it takes longer to do it. But it is worth being aware that most risk capital carriers, insurers, reinsurers are investing in this space, are investing heavily. There's an arms race to be as clever as you can possibly be using that data and advanced models. But I would really encourage everyone, if you haven't already, start at the top, think about using an AI productivity tool in the context of your own daily work, and I guarantee you will become hooked once you start doing it, and that's a sensible place to start from. Okay, I've got 3 example use cases here, which are more advanced and I guess more tailored to insurance. The first one that I have here is really leveraging those vision models that we talked about earlier. We have an example and a picture here of a United States wildfire agent. So the idea is that there's a lot of information that's required to understand wildfire risk for a property exposure. We had a lot of wildfires at the beginning of the year in California. And the idea here is that by taking satellite images and pairing that with AI models that can extract information from those images, we can quickly build systems that enhance the underwriting workflow. I'm not saying replace the underwriting workflow because, as I said before, models aren't always correct. But I want you to imagine an application where you type an address, it pulls up a satellite image, it gives you a whole bunch of information, in this case, the building footprint. It's highlighted where the trees are, which is really, really important from wildfire risk perspective. It's got some different statistics, a different wavelength, a whole trove of information which AI can talk to and present to the end user. And the trends that we're seeing in the market just now are that more and more companies are investing in building out these kind of underwriting workflow tools, which are used, again, as a multiplier to try to automate and expand the amount of data available at time of underwriting. Not really automating underwriting in itself, because that can be problematic. We will come to that in a moment. But really as a new way of bringing in new data. Second use case that we see a lot of activity in, and that's really around claims. So obviously, the largest outflow of money from the value chain in insurance is, thankfully, to pay claims for insurance. But claims management is a tremendously complex process. You have highly experienced claims adjusters and professionals who spend a lot of time working with claims, which can be weird and gnarly and difficult. One of the things about the claims process that you don't see as much compared to other operational parts of the insurance process is that there's a lot of that unstructured data that I talked about. So there's a lot of text data, think claims descriptions, pictures of incidents, and it's an absolute treasure trove of broadly unmined information that's typically not being used at scale to try and drive efficiencies. So one of the things that we see a lot of with AI is trying to really get to this claims lifecycle system. And a claims lifecycle system is essentially just at the top, you maybe have a claim notification, like a first notification of loss or a claim update. Then you have an AI model which is able to extract and understand some of the information contained within that, and then feed that information into a bunch of models. I've given some examples here. So for instance, a litigation model might be it takes claims descriptions and values, and it tries to estimate what's the probability of that claim litigating. So for instance, in the US, litigation is a big problem, can get very expensive. So quickly identifying when something is likely to litigate is relevant for deciding on settlement. So by building this AI system, we can quickly try to move from raw data, unstructured data, extracting the information, applying it to downstream models, and quickly tagging claims that require attention now. And if we deal with them now, we hope that in the long run, we're going to save a ton of money. So there are many providers working in this space. Claims is underdeveloped from an AI perspective relative to underwriting. I think that's fair to say. And you see a lot of focus here just now. Last advanced use case that I have as a talking point, at least anyway, is submission and underwriting triage. And the idea here is that many kinds of insurance have, I'd say, inefficient onboarding. So the process of quoting, binding, or setting terms has a lot of handle points. There are people touching different data. So for instance, a lot of insurance is transacted via manual submissions or an email submission. Some is done via API, but a lot of insurance is still transacted in a very manual way. And the idea of having an underwriting and submission triage is, can we use these models to really sort through the low quality prospects? What do I mean by a low quality prospect? If you have, let's say, an email submission of a particular risk, there might be 5 things that you need to quote, 5 pieces of information. You can quickly build an AI system which checks that before I even look at this particular submission and email, are those 5 pieces of information even in the email? Or does it have to go back to where it came from to ask for more information? And the idea is that by applying AI, you can quickly sort and filter out the areas that are probably not going to be viable in the first place and really focus on the areas that are. So we see a lot of activity there around underwriting workbench and really making that process more efficient. Okay, regulation and fairness. There's only one slide on this. It's tremendously important. I said that AI models are broadly new from a public point of view. There's been a whole bunch of challenges that have been brought about. We saw some of the rough edges earlier. If the models aren't always right, and you don't know where the data came from, and you're sharing data across different organizations, regulators are going to become involved in that. And they're particularly going to become involved when the application of the AI is related to the provision of essential goods and services. So things like insurance. So I've got 2 pictures here, one from the EU, one for the US. There are other bodies. This isn't exhaustive. But we see in the last couple of years, the EU focusing on its Artificial Intelligence Act. There's a link there. You can go and read it if you like. You will need a few hours and a lot of coffee. And there's also some guidance there from EIOPA, so that's the European Insurance and Occupational Pension Authority, which is a bit more specific to insurance. The bottom diagram shows the current, or as of last month, adoption of a particular brand of AI practices for US admitted market business. So if any of you are working in a US admitted market space, you will be subject to these regulations within insurance. I guess I would say there are so many different brands of legislation coming out from countries, from supranational bodies, and it's a very dynamic landscape. So it's very difficult to keep on track of. What I would say is that they are almost all the same, and that they are broadly common sense, but very verbose, but very common sense, and that they really focus on transparency, explainability, and human oversight in using AI. So essentially making sure that companies don't use low-quality systems which disadvantage consumers. Now, I would say that for those of you that have been in insurance for a while, you will know this is a regulated market. You already have professional responsibilities. You already have memberships of bodies. You already treat customers fairly. Starting to fold in AI and taking on the additional burden of complying with AI regulation isn't some foreign process. The insurance landscape is already heavily regulated. So I really do think this is an evolution and not a disruption to using AI within business. And I think the challenge is finding use cases that deliver efficiency and deliver returns that adhere to the regulation that prevails in whatever market you operate in, and not avoiding using AI because you're overly worried about the regulation prevents you. The regulation typically doesn't prevent you really from doing anything. It just wants you to be very sure that the systems work and you document it and you're fair. So I would encourage you to read more and seek advice as appropriate as you use these tools. Okay, last section. I said at the top, I think I'd laid this out very much from the point of view that's the first steps. I've made an assumption there that most people are taking the first steps in using AI. The first element I have there is start small and start now. I've said a few times that I find tremendous personal value in using AI in almost everything I do. And if you do one thing from today, I would encourage you to go and try using a large language model to help you do some of the menial stuff that you don't like doing as you go about your work and personal life. The second point is about agility. I think the really interesting and impressive thing about the MGA model is that most MGAs are tremendously entrepreneurial. And one thing you might think is it probably takes time and expertise and investment to use AI, which is true. and that you're at a natural disadvantage to, for instance, risk capital or other distribution models. And I don't think that's the case. One of the things that you see is that large organizations, in adopting any technology, tend to stumble and have false starts. I spend a lot of time talking to a lot of insurers and reinsurers, and I would describe most carriers' attitude towards using AI as being in very early stages, slightly chaotic, and full of indecision. And one of the things about the MGA model is that MGAs are nimble by design. So I think there's a real competitive advantage there to being decisive and moving forward at speed. Last point on this slide, you don't have to. I spend a lot of my time building custom AI models, and that's fine. I work for a large company, and we have lots of areas where that makes a ton of sense. From an MGA perspective, you don't have to be building everything yourself. There are a bunch of tools. We've talked about off-the-shelf LLMs. There are other kinds of AI tools that you can use to try to help you get better at whatever it is that you do and whatever your distribution path looks like. So you don't have to build everything. Have a look at what solutions are available in the market. The next thing I think it's after you start hopefully gaining productivity gains from using AI in your everyday work, pick something that's a bottleneck in your business. So it could be the example of pulling information from emails. It could be you have to summarize meeting minutes. It could be you have to write meeting minutes. But choose a task that's a blocker within your business and try to use an AI tool to build something that answers that particular problem. Check that it works. Be honest with yourself, because sometimes it doesn't work. If you get to the point that you are starting to think more carefully about investing time, effort, and money in this, I would consider partnering for success. That could be risk capital. It could be finding external expertise. It could be just doing some more research, assigning some budget to training your staff to get better. And I guess I would say, before you go running off and spending money on this, I'd really encourage you to get super comfortable just using the everyday AI in everything that you do. Last part, actually I have to say this, educate your team and stay compliant. I've hopefully tried to lift the lid a little bit and try to demystify what AI is and isn't. I've spent a long time in this field. It's not magic, it's mathematics, but it's really, really powerful. If you're going to use AI, particularly within regulated markets, you have to invest in understanding, firstly, how to use it, what the risks are, limitations, and make sure you're being responsible, particularly in dealing with customers. Okay, we skipped these at the beginning. So, the session's learning objectives were defining what AI is in practical terms. We've talked about models. They are big models. They are models that perform tasks which feel human in some way. They're not magic, but they're really cool. We've described some high-level use cases of where AI fits in P&C insurance. I had a 4-stage sampling of different applications, and as well as some advanced use cases that we're seeing in the market just now. Given a very high-level summary of regulation, the reason for regulation, and where we are just now around using AI in insurance. And then we had a very quick run-through of some practical tips of getting started. So that's pretty much everything I had prepared. I thank you for your attention and look forward to any questions.
You do have some questions. We've got 2 questions. So the first question is, what do you see as the most transformative use of AI in the MGA space over the next few years?
So I think from my point of view, where we're seeing the most gain is, I would say, lubricating distribution. I think there are many MGAs, not every MGA is the same, but there are many MGAs that really have to deal at the coalface with customers, with delegated distribution, dealing with different broker channels, and the data flows typically are not great, or typically MGAs have a lot of staff that are doing jobs that are quite menial. So from my point of view, if I were running an MGA, I would really want to try and be as lean and as fast as possible. So I had that example there of trying to use a distribution triage system or underwriting system to really try and make sure that my staff, my underwriters, are focusing on the risks with the highest impact. There's a lot of different things you have to do to get right there. But I really think there's a tremendous opportunity to use AI just to really make that intake of data information submissions more flexible. I don't think anyone's got it right yet, but the tools are particularly adept at that task.
Thank you. And your next question, just make sure I've got it all here. Do you feel that, MGAs should build internal AI teams, or should they rely on an external partnership?
So, if you'd asked me a year ago, I'd say you probably need to partner externally. I think one of the interesting things that's happened with this rapid productization is that most of the tools, I'll take ChatGPT as an example, you can buy and license a tool like that, and they're increasingly adding functionality that allows you to customize what that tool can do. So I think if you were developing an AI tool 2 years ago, 3 years ago, you would be hiring software developers and coding people and nerds like me. I think where we've got to with the productization is that actually a lot of customization is now built into these tools and offerings already. So I think what that means is that I think many businesses could leverage more advanced AI capabilities without hiring nerds and PhDs and coding people, but instead I'd say probably hiring and training some business experts. So people who are an expert in whatever problems it is you're trying to solve, perhaps that's current employees, training them in AI and having them modify and fine-tune the models to use, fine-tuning the off-the-shelf models. And I guess I would say, if you start using some of these tools, have a look at the settings within there, because many of the model providers have provided really easy ways to go and customize things. And the way you customize them is just with human tips. You just describe in a bit of detail exactly what you want the thing to do. So I would encourage you to see how far you can get with minor customization. If you then start going to something super bespoke that, I don't know, you're building a custom vision model because you are, let's say you need a vision model because you work yacht insurance, and there's not a good off-the-shelf model that's good at telling you whether a yacht is good or bad, then that's going to be tough. If it's anything super specific, then I would probably reach out to a consultant.
Thank you. And we've not got any more on the chat, but there may be some people typing, so I'll give them a bit of time to get that through. I just have one question myself. You mentioned in when you were discussing your everyday and your use of AI and the time saving and how much you use that in your everyday tasks. And without wishing to call any of your responsibilities nerdy, but if we exclude that side of your role, what's your, I suppose, the biggest time saver you find using AI in sort of really everyday tasks that we all might do?
When I'm trying to solve something complex, I often find it very difficult to get started. So one of the main value adds that I have is, let's say I'm preparing a report or a framework, and I'm going to do a presentation like this. I will sit down and I will describe to a chatbot, I need to do this presentation to MGAA. These are the kind of people who are going to be there. These are the rough ideas of things that I'd like to say. And I go through this human/machine imagination exercise where it's back and forward. I think that from my perspective, and this is just from me as a person, I typically, if I were to do that myself, I would procrastinate because I find it boring. So for me, that kind of sequential imagination process gets me to, it goes from 0 to, okay, I've got a framework of 12 slides and 7 concepts, and I've done all of that in 15 minutes, and then I go and fill in the gaps. So that's the main area that I use it for. And as you say, there's a bunch of nerdy stuff that we use it for too, and writing code and things. But as a planning tool, as a research tool, and mostly as a helping me solve large abstract problems that I would waste time on otherwise.
Thank you. That's really really interesting. And did AI come up with the panda example?
No, my eldest daughter came up with the panda example. She chose it because she thought it was fun.
That's good because I've not seen any of our briefings that have featured pandas, so that was an excellent choice. And we have a question. Are there any AI tools that Accelerant have adopted that have really assisted underwriters? Could these be used in the MGA space also?
I think I would say that I talked about how there's a bunch of off-the-shelf chatbot kind of tools. I would say that the underwriting AI tools are still immature. We actively research and we actively work with different vendors to try and understand the best possible tools. We develop some of our own, but I wouldn't feel confident enough to make a recommendation of a particular vendor just now. I guess I would just take a step back and say that, much like I keep saying, a year ago the world was terrible and now it's amazing. The way that tools have come on in the last year, I'm expecting far more vendors to come to market over the next year because the tools are much, much stronger. So I would just encourage you to stay tuned with the vendors in the market.
Thank you very much. And I think with 2 minutes left, this doesn't often happen in our briefings, we may well have run out of time for any more questions, unless anyone's very quick. So I just want to make sure we get thank you in. So thank you to Kelly for that very, very, very informative session. And fingers crossed it will save us all a little bit time in some of those tasks. And we have got a thank you popped up. Very fascinating session. So thank you again to Kenny for the spending the time. And I know that AI didn't do all of the work on your presentation. You must have done some, and not your daughter. It was you as well.
It was a team effort. Okay. Thanks everyone for your time.
Yes, and thank you everyone for joining us. And if you haven't seen the first session, it is on demand as well. So thank you very much. That leaves me just to leave you to enjoy the rest of your afternoons.